Hello and welcome to today's video about scientific notation. First, let's talk about some important vocabulary that you will need to know and understand for today's lesson. Expanded notation. This is a way of writing a number as the sum of the values of each digit. For example, 356 is the same thing as 300 plus 50 plus 6 in expanded notation. Scientific notation. This is a system for representing numbers in which a number is written as the product of a power of 10 and a number that is at least 1 and less than 10. Scientific notation allows you to write large and small numbers with only a few symbols. For example, in scientific notation, 4,300,000 is the same thing as 4.3 times 10 to the power of 6. Now let's talk about translating scientific notation. In our last video, we talked about writing powers of 10 using exponents. This, scientific notation, is just an extension of that. Let's look first at the number 65 million. If you remember from the vocabulary slide, we talked about scientific notation being the product of a power of 10 and a number that is also smaller than 10. In this case, we're going to look at the number 65 at the beginning of this number. We're going to change 65 into 6.5, and we're going to multiply it by a power of 10. Typically, all you would have to do is count the number of zeros, 1, 2, 3, 4, 5, 6. But in this case, since we added a decimal as well to keep our number below 10, we're going to count this 5 as if it were a 0. And instead of adding a 6 as an exponent, we're going to add a 7. So 65 million is the same thing as 6.5 times 10 to the power of 7. This is mostly because the 6 right here really stands for 60 million. Your exponent reflects the number of zeros that would come after the largest place value represented in the number. Let's look at the number 1,500. This is going to be much the same. We're going to change the 15 at the front into 1.5 and multiply that by a power of 10. We're going to multiply it by a power of 10 to the 1, 2, 3, again counting that last number that comes after the decimal in our multiplication problem. 35,000 will get changed to 3.5 times 10 to the power of 4, because there are 1, 2, 3 zeros plus this 5 which comes after the decimal. And 230 million is going to get written as 2.3 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, and 8. That 3 is going to count again because it comes after the decimal on the right side of this problem. Finally, let's talk about expanded notation using these numbers. In expanded notation, we are simply taking a number and pulling it apart to show all of its parts and what the value of each of the digits is. So let's look at the number 2,794 first. In expanded notation, this number will look like 2,000, because that's how much the 2 is worth, 700, because that's how much the 7 is worth, 80, and 4. You'll notice that I wrote all of these numbers with an addition sign in between each one, and that is because if you were to add these numbers back together, you would come back to this original number. Now let's look at the number 395. If we pull 395 apart into its expanded notation to represent the value of each digit, we end up with 300 plus 90 plus 5. Let's look at this number 50,406. In this number there are a couple of zeros and there are a couple of different ways that you can choose to represent this. The way that I prefer to see you write a number that has zeros in it using expanded notation is this. Starting out with 50,000 plus 400 plus 6. In this case, you'll notice that I skipped the 10,000s place and the tens place because those are both zeros. You can, if you choose, represent those place values by writing in zeros, and it would look like this. 50,000 plus 0,000 plus 400 plus 00 plus 6. And that's also right as well, but it's a little bit more work. I prefer, when I have to write these down, to just skip the zeros and write the number out like this. Here is your practice problem for the day. Write the number 86,000 using scientific notation. Then write the number 9,284 in expanded notation. Good luck!